In the video of lecture 1 part A, we were discussing we were performing this question that is given to fuzzy sets. You have to perform, you're asked to perform union, intersection, complement and difference operations. Yeah, we have discussed the union operation, intersection operation, and now the complement operation. Right. So how we will perform the complement on fuzzy set A? That is defined as 1 minus membership of A of x, right? It's simple. That is, consider the fuzzy set A here, that you have to subtract the membership value of each element from 1. That is 1 minus 1, it is 0. Hence the resultant membership value of 2 in A complement, it is 0. For element 4, you have to subtract 0.3 from 1. So it is 1 minus 0.3, it is 0.7. Similarly, for element 6, you have to subtract 0.5 from 1. 1 minus 0.5. So that is equal to 0.5, and you can apply the same operation to the element 8. Right. And the resultant answer for the question of A complement is given. Similarly, you can apply the same for B, right? That is B complement is equal to 1 minus membership of B of x. Here consider for element, the membership value is 0.5. So 1 minus 0.5, it is 0.5 itself. For element 4, it is 1 minus 0.4, it is 0.6. And for element 6, it is 1 minus 0.1, it is 0.9 in the resultant. And for element 8, it is 1. 1 minus 1, it is equal to 0. And the resultant solution is given here. Now, the next operation you are asked to perform is difference, right? So, A minus B is mathematically given as A intersection B complement. It is given as A intersection B complement. So, you have the B complement. You have already evaluated the B complement and A complement here. So, this is for B minus A. So, A intersection B complement. So, it is intersection operation. So, you have to take the minimum of the resultant. So, minimum of 0.5 and 1. For element 2, it is 0.5. And for element 4, minimum of 0.3 and 0.6, it is 0.3 for element 4. And for element 6, the minimum for among 0.5 and 0.5, it is 0.5 itself. And for element 8, 0.2 and 0.8, it is 0.2 itself, right? So, this is A minus B. There is some correction at this particular element. Please check with the previous values. Sorry, this is no, I made a mistake in the slide. That is, the solution is 0.2. Solution is 0.2. So you can write it as 0.2 by 8. That is, the membership value of element 8, it is 0.2. Similarly, you can perform the same set of operations here for B minus A. The difference between B and A. Now consider the third question is that you are given two fuzzy sets. You are asked to perform these operations from A to J. These are the questions. You can do it. Please practice and try to understand how to solve. The solution is there in the slide. Now you are asked in the next question, you are given two fuzzy sets. You have to perform these four operations. That is, you are asked to find algebraic sum, algebraic product, bounded sum, bounded difference, right? So the two fuzzy set is again shown here. A and B is given here. To perform the algebraic sum, mathematically A plus B is given by membership of A of x plus membership of B of x minus membership of A of x into membership of B of x, right? So what for this part you have to perform element wise multiplication of the membership values. That is 0.2 into 0.1, it is 0.02. 0.3 into 0.2, it is 0.06. And 0.4 into 0.8, it is 0.08. And here 0.5 into 0.1. 0.1, it is 0.05. It is 0.05. There is a small correction here. 0.1 into 0.5, it is 0.05. Alright, so and for membership of a of x, this sub part of this the expression, it is membership of a of x plus membership of b of x. You have to add individually. The membership value of each individual elements is added up. So 0.1 plus 0.2, it is 0.3, and 0.3 plus 0.2, it is 0.5. Again 0.4 plus 0.2, it is 0.6, and 0.1 plus 0.5, it is 0.6. Again there is a correction here. Alright, again this minus this would give you the resultant value. So 0.3 minus 0.02, it is equal to 0.28, and again 0.5 minus 0.06, it is 0.44, right? And here 0.6 minus 0.08, it is 0.52, and 0.6 minus 0.05, it is 0.55. So the resultant answer is here. So please consider this correction in your slides also. Alright, now the algebraic product is also given here. You have to consider this subpart, right? Membership of a of x, a into b is given as, a dot b is given as membership of a of x into membership of b of x. So you have to multiply the membership value of each element. So 0.2 into 0.1, it is 0.02, 0.3 into 0.2, it is 0.06, 0.4 into 0.2, it is 0.08, and 0.5 into 0.1, it is 0.05. Bounded sum. So in this bounded sum, you can see that the expression is given as minimum of 1 comma membership of a of x plus membership of b of x. In this particular, these two operations, these two operators, they limits the boundary between, or makes the value of membership value between, limits the value between 0 and 1 of each element. So what does it, the operator says that it is minimum of 1 comma membership of a of x plus membership of b of x. So in this part you have to add it up, and you have to once added, you have to consider one, or take one or the corresponding membership value. Whichever is minimum, you have to take it. Now suppose this is not the exact solution. Anyway, consider this part. If this is if the value, membership value exceeds 1, then you have to make the boundary, that is you have to consider minimum 1 or 1.5. 1 is the minimum, so the resultant is given as 1/4. But according to the question, there is a small mistake here. This resultant is not 1.5, it is only 0.6. ഞാനത് മനസ്സിലാക്കാൻ വേണ്ടി പറഞ്ഞതാണ്. അപ്പോൾ അതിനെ നമുക്ക് ക്വസ്റ്റ്യനെ നമുക്കൊന്ന് അപ്ഡേറ്റ് ചെയ്യാം. അതായത് this is save. How to make 0.5? Let it be 1. If it is 1/4, then the resultant would be 1.5/4. So the resultant, you have, when you apply the bounded sum, you have to consider the minimum between 1 and 1.5 for the element 4. So the resultant would be 1. Right. The others remains the same because these values are less than 1. So the membership value of 1, 2, 3, elements 1, 2, 3 remains the same, but 4, it is 1. Right. Bounded difference, you have to consider the expression is given as maximum of 0 comma membership of a of x minus membership of b of x. Right. So you have to perform the subtraction operation here. Right. So here again a small correction. 1 minus 0.5 minus 1, here it is minus 0.5, right? Minus 0.5. അങ്ങനെ വിചാരിക്കുക. ഒരു ചെറിയ കറക്ഷൻ പ്രീവിയസ് ക്വസ്റ്റ്യനിൽ നിന്ന് കൊടുക്കുക. ഇത് കറക്ഷൻ ഉള്ളത് നിങ്ങൾക്ക് പെട്ടെന്ന് ഈ ബൗണ്ടഡ് സമ്മിൻ്റെയും ബൗണ്ടഡ് ഡിഫറൻസിൻ്റെയും അഡ്വാൻറ്റേജ് മനസ്സിലാവാനാണ്. അതിലെന്താ ചെയ്തിരിക്കുന്നതെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഈ 4ൻ്റെ മെമ്പർഷിപ്പ് വാല്യൂ എയിൽ ആസച്ച് മെയിൻറ്റെയിൻ ചെയ്തു, ബിയിലുള്ളത് 1/4 എന്ന് ഞാനിവിടെ കറക്റ്റ് ചെയ്തു. അപ്പം ഇവിടെ എന്താ സംഭവിക്കണമെന്ന് വെച്ച് കഴിഞ്ഞാൽ 0.5 മൈനസ് 1 എന്ന് പറയുമ്പം ദ റിസൾട്ടൻ വുഡ് ബി മൈനസ് 0.5 എന്ന് വരും. 0.5 by 4, right? The membership value of 4 is element 4 is minus 0.5 in the resultant solution. Now you have to take maximum. 0 or 0.1 is maximum. It is 0.1 is maximum for element 1. Similarly, for element 2, the resultant would be 0.1. And for element 3, 0 or 0.2 is maximum, 0.2 is maximum. Hence, for 3, the membership value is 0.2 again. But for element 4, the membership value is 0 or minus 0.5 on a maximum. The 0 is maximum. So the resultant for element 4 would be, the membership value for element 4 would be 0 by 4, right? Or the membership value is 4. So I hope you understand the significance of bounded sum and bounded difference. Anyway, please get yourself corrected. This is, I have updated the question as for B it is, the membership value is 1/4, right? That's all for this video. Thank you.